Hello everybody. In this video I'm going to teach something about electronic, and you can learn electronic in this way. It's very fun, it's very simple, and it's really practical, and you will learn to become a good engineer. So I learned in this way, and I intend to teach you guys in this way. So let's go and start. Of course, if you want to learn electronic, you don't need to have any background about electrical, because I'm going to explain all of this fundamental uh, and everything to you at the right moment. But right now, we're going to start with microcontroller. With microcontroller, we are uh, coding some code so our microcontroller operate the way we want, and in time and in the next videos we are going to add more and more component and learn about each one of them. So I think it is the best way, and let's go and learn about the electronic. For start, I just add a microcontroller here on pick. I'm gonna click on P and search AT Mega 8. It's a very simple microcontroller. We can use it for our work here. And we need a resistor and some LEDs. You know, LEDs is just some kind of light emitted diodes, and there are some kind of light bulb, but it's uh, an emitting diode. So of course, if you want to add an LED, you should add the active one, because the device or the analog one does not show anything on the simulation. If you want to watch some animation behavior of that component, you have to use the active one. It's blue, green, and red. Okay. Each microcontroller have some devices inside it, such as IOs, ADCs, interrupts, serial input, and many devices is inside this microcontroller. But right now we just want to use the IO device. So as you can see, all pins can operate as IO. They've been called like PB0, PB1, PB2. It means port B0, port B1, port D1, port C1. This microcontroller have three ports. Uh, the 8-bit microcontroller are have 8-bit each port. So that's why they call them 8-bit microcontroller. Uh, okay, I'm going to add some LEDs here. It's a red, green, and the blue one. And I will connect each LED to a port of microcontroller. So C0 means the blue one, C1 is the green, and C2 is the red one. I'm going to put some resistor on unnecessary with the LEDs, and I'm going to tell you why. If you want to move electrical current through a component, you have you have to put a source. For example, here our source is our microcontroller, and it have to goes to another potential. For example, here is our ground, and it means 0. I'm going to put some prop here. In this props, you can just see what's the voltage of this point compared to 0. And there is a current probe. I'm gonna put here, here, and here. Remember, when you want to put a current probe on a wire, uh, you have to be careful. The direction of this flash should be on straight with it must be parallel to the wire. This one should be just rotated, and now it's okay. Of course, you can mirror it here. It's the opposite, but it show our current in negative. Okay, now we're going to and just write some easy code on our Bascom. Okay, in a Bascom, as the first code you ever write, you should write which microcontroller you are using, and you should use this code $reg file. It show you many type of microcontroller, but you can just say M8 def that, and it's good to go. And it shows in blue. And the second code should be the operating frequency of the microcontroller. We type in $crystal equal Each microcontroller have different operating frequencies. For example, for 80 mega, it's 1, 2, 4, and 8 megahertz. Of course, you can raise it to 16 megahertz with external crystal, but the internal oscillator can just make a frequency about 8 uh, megahertz. Okay, now what do we need here? We need to just send a signal out. It means just we want to use our port as an output. In output, you can just choose this pin can be 1 or 0. 1 or 0 means 5 volt and 0 volt. So we want to make it an output. So we say DDRC dot 0. It means uh, pin C dot 0 equal 1. 1 means output and 0 means input. I'm gonna write both of them. Yes, this sign means this code is uh, just for your view, and it doesn't operate in our code. It's for input and it's for output. Of course, it must be like this. Okay, DDRC and 2. So we make these 3 pins as an output, and we have an end. End means it's the end of our program. So I'm going to make a loop. They call it do and loop, do loop. In do loop, the program in here work infinitely. Okay, now we want to send a signal out on port C.0 as an output. We want to just make the LED light. So we say port C.0 equal 1. It means it's 1. It's 5 volt. Wait ms. Wait millisecond. 500 millisecond or half a second. And we say then turn off the LED and wait 500 millisecond. So it works infinitely. So our LED on pin C.0 is going to flash in half a second, and it's gonna do it infinitely. Okay, we compile our code. If you want to compile it, you can just push the F7 button on your keyboard. Okay, in here we should double click on our microcontroller, and here we should choose the right frequency. It's an internal 8 MHz RC, and in here we just add our program file. The code hex means the right program we need just to for this software. Okay, we uploaded the code, so it should be work fine right now. We started. Okay, our LED is blinking as you can see here, but it's 0 volt, 5 volt, 0, 5, 0, 5, but it's not flashing. What's the reason? It's because of this resistor. This resistor is too high to let the LED work. We should just make it 1 kilo. Now, as you can see, it flashed. It's blue, but it's very dim. So let's just make it to 4700. Now it's better. So as you can see, our LED is flash in half a second, and we just write a program. You can use this for example many system you might need in your home or your work or anything. So as you can see, it is a very simple circuit, but it's really useful. Okay, I'm going to explain this code. Do loop means a loop with infinite number of time. Port x dot x means the right and the specific pin on the microcontroller. Equal to 1 means it should be 1 or 5 volt on output, and equal to 0 means the output is 0 or it's ground. Wait means the program stay in a specific time of loop. It means the program wait for the specific second. For example, we have wait ms and wait us. It means it's in second, in millisecond, it's in microsecond. And you should know about milli, micro, or other. Okay. Now I'm going to flash the other LEDs too. One. It means the third LED is flashed opposite the other two. Okay, I'm going to hold it here and see about the current. The current is 0, 0, 0, but this one is negative this much. Okay, we play it. Now this is 0 and this 2 is here. You can see the current in here. Okay, now you can see the codes, how did they work, and you can just add as much as you want LEDs to the pin, or you can use other component and you can drive them, and it's really easy. So in this video we learn how to program a microcontroller, how to use a simulation software, and we use the I/O of microcontroller. uh, you can make the microcontroller pin as an input or output, and of course here we just use the output, not input. The input I will going to show you in the next video, but right now in this video we learn about the do loop, the wait, and an output. So you can use this code to make variety of system, whatever comes in your mind, just start making it, and it's really easy and fun. So good luck.